Hey guys, this is DIY or Die. Today we're going to be talking about electrical shock. So I'm going to use this multimeter here to show you, first of all, the potential between the terminals there and the terminal to ground, so hot to ground and hot to neutral. We're going to show you that here on the meter, and then I'm going to show you my body resistance just at different places in my house, and then from there we're going to figure out, we're going to kind of dispel the myth, I guess, or kind of make electricity less scary to people, because people think that if you stick your knife in the toaster you'll die or something. So today I'm going to show you that that's probably not the case. So yeah, let's get started here. Okay, so got my meter here. Just gonna put one end. It really doesn't matter. That's technically the hot, but you don't really need to pay that much attention. So there we go. Plugged her in, and looks actually pretty low today. Not pretty low, but usually it's about 125. I think it's actually kind of on the higher side. But anyway, so yeah, 121.6 volts. The red lead here is going to be the neutral side of the outlet, and the black lead is now going into the ground side of the outlet. And so there's actually a little bit of potential difference between the neutral and the ground. See, it's about half a volt. See, if I take this out, of course it's floating and stuff, but voltage to my finger, less so. Anyways, so I'm going to put this back in the hot, the black one, and I'm going to put the red one in the ground. So now we're seeing the hot or the line to ground voltage. 10 is just probably no connection. Yeah, this is just kind of a capacitive thing going on here. If I actually it's kind of loose in there, but if I actually probe and hit the ground terminal, we get, see, 122 volts to ground. So now let's check my resistance here to ground. Hopefully I can get this to stay in here. Lowest I could see there is 15 mega ohms maybe. I'll try to stab it into my finger here. Yeah, I really can't get it very low. So hand to hand now, thumb to thumb, squeezing them pretty hard. Yeah, see, if I really squeeze it I can get it down to, let's say, it's like 80 kilo ohm, 80,000 ohm. Still pretty high, but yeah. And if I measure from my foot to my hand, see, we get about half a gig ohm there, 400,000 ohm. If I push my foot harder into it, yeah, so I'd say it's safe to say even you're going to be looking right around 100 kilo ohm. Of course, in industry that you have a standard specified hand-to-hand voltage, so across a human basically, a hand-to-hand resistance, sorry, across human, and that is determined to be about 5 kilo ohm, so 5,000 ohm, which is considerably less, but that is once you're past your outer layers of skin, I should say, and because your outer layers of skin, they're very, it's very dry, so they don't conduct. It doesn't conduct very well. But say if you have an arc or something that penetrates the skin, or you get impaled by a conductor or something like that, stabbed by one when you're, I don't know, doing a connection. Once it passes through those inner layers of skin, that's where you have the potential to be really badly shocked and killed, probably. But so the next thing I'm going to show you guys is I'm going to show you the current from line to ground through me. Okay, so I got myself a nice grounded plug. It's just one of those standardized connectors for the power supply. Let's plug her in. Now I'm going to probe off this instead. Perfect. A nice firm connection in there now. Let's do voltage, and let's just double check. Sure enough, 122.5 volts. So we know we got a good connection there. So we got ourselves a good ground now. Now I can take that, leave that there. And now I'm going to touch this. And of course, touching this wall screw, you got an ohm there. So I really can't get any result here. There's not anything super repeatable. See, now if I was to say touch this and then touch this like this, see, we're getting a reading. So it's not like my connections are wrong. Anyways, this further illustrates my point that it's pretty hard to get shocked. I'll stand on the carpet. Definitely an over limit situation. I mean, you can see it's briefly. Now I don't know if it's because I have some sort of weird, it's some kind of weird potential thing, or if I'm like, it seems to go up as I think it's just is too high for the meter. Anyways, the fun part is when I go like this. So I'm going to take this, make this hot. So this is now the energized side of the plug. Now I'm going to pick this up and we're going to go to voltage. Touch this. Of course, this is a multimeter. This is actually safe to touch. Well, I shouldn't say it's completely safe. Nothing's completely safe, but this is, you're not going to get hurt from touching a live sided piece of equipment and touching the other end of your meter. It's not going to do anything. This just shows my potential from the wall outlet there, minus some drop in the cable, which is nothing. Anyways, the wall outlet from there all the way to the ground I'm standing on here, which happens to be 108 volts alternating current. Quite significant, right? That's practically 110, 120. So now this should give me a better result. Actually, I bet you if I touch this, see, we get the full voltage, practically 119. Now I'm on 2 feet. I'm going to stand on 1 foot here. So we're getting about 104. Put my other foot down, 110. So even that, you're seeing it's a much more noticeable difference rather than using a resistance function, just because of the way the voltage drop works across me. So hopefully you can see this angle here. So now we go from 110 roughly. I'm going to stand on the carpet now. So immediately there's a difference. We go from 110 to 55. That's literally half the voltage I'm going to be receiving across me here. So just one step, I'm at 100 volts. Back on the carpet, 55 volts. So, I mean, it's hugely dependent on where you're standing. I'm going to quickly go to the upstairs portion of my house, just main level, ground level, not basement level, and we'll see the difference that makes. Alrighty, so I made it to my kitchen now. Again, tile flooring, straight from the outlet here. Okay, so we're plugged into the hot side of that plug there. And you get that weird voltage from the floating, or weird floating voltage, doesn't matter. I'm going to touch this. Just look at that. Now it's only 57 volts. And we're on essentially what would be considered a good grounded material here. Just like downstairs, but we're basically now equivalent to the carpet on the basement down there. So, I mean, it just shows you how unideal a shock would be. Like 57 volts, that's practically considered ULV, ultra low voltage, which is, I mean, that's more or less DC usually, but that's 30 volts and under. So, touching the coffee pot gives me some more. Anyways, but yeah, so that's just, it's creeping down into the safe enough you don't need protective equipment near live terminals voltage. I'm going to go over there, just on the carpet there, and we'll see what it looks like over there. Okay, so I got the plug there. Again, plugged on the hot side of there. And now I'm on the carpet, of course. away from the kitchen, main level, and kneeling down affected it a little bit, but 30 volts. So that means if I was to touch that directly, I would only be having 30 volts push current through my resistance, which would mean that I would essentially have no current going through me. So yeah, 30 volts, nothing to be scared of. I will now work my way up. We have to be careful now because I'm going to set this to current measurement in microamps, because I really doubt we need milliamps. Trust me, if I'm in milliamps, I'm kind of entering dangerous stuff there with milliamps. But so now we have a direct connection from the hot terminal of that wall, and on the other end of this, I'm going to touch it. So this is hot right here. This is showing you the microamps. So I'm touching live right now. This is live. 2 fingers. Look at that current. I can't feel it. No, I'm not feeling anything. This, when you're in the microamps, that's tiny, tiny there. 3.8 microamps of AC current. Nothing. If I push harder into the ground with my feet, just on my heels there, I can get about 4.5. Still, nothing to be concerned about. If you can't feel it, you don't really have to worry. Lethal currents are in around the 5 milliamp range, so we were at 5 microamps, so that's a whole order of magnitude away still. So let's go back to the kitchen and then see what the current is there. Plugging it in. Direct connection. I'm just going to quickly just tap this in case. So, 2 feet, tile floor, live 120, 10 microamps. Again, can't feel it. To the basement. It's a lot higher than I expected. That's 106 microamps. But yeah, good solid grip on there. 110 microamps. So my point here is that symbol right there, that symbol right there is micro, meaning millionth, meaning we are talking 100 millionths of an amp going through me. A milliamp is 1,000 microamps. So, and it's around right around a milliamp is when you start to perceive electrical shock. So if a milliamp is 1,000 amps and that's the perception threshold, then when I was standing on a well-grounded basement on at a 120 volt potential, I was getting 1/10 of that. 1/10 of the requirement to perceive the shock. Not even for potential damage. That's usually around 5 milliamps, and that's being pretty generous in terms of its effect on your body. Because like this would be it's not like I'm going hand to hand with this type of situation. I'm going to quickly, before I blow something up, but this is not a hand-to-hand situation going across my chest. I might get some current going through my chest here, but it's nowhere near as bad as a hand-to-hand incident. And I'm not going to try that because that's just stupid to try that. But yeah, my point being, American voltages are, one, low in terms of line to ground voltage. They're very low. I mean, Europe has 240, which I think is personally better, but that's besides the point. It's low voltage. You have GFCIs right here in places like a bathroom. I mean, sure, it's not going to be in your basement everywhere because in a basement you have better grounding, but this is set to go off, a good one will go off at about 5 milliamps. And so that, like I said before, starts getting into the danger zone. So these do a good job of protecting you if you do have a hand-to-hand incident or a really, really bad line-to-ground incident. Furthermore, so now we're back up top here, back upstairs, and this is the item of choice here. This is the one that everyone says, oh, don't stick your fingers in the toaster because you're gonna die, you're gonna get electrocuted, you're gonna get, you know, killed. But I just proved to you guys that even if I stuck a fork in this outlet and I was touching it, I wouldn't even feel anything. if I stuck a fork in here, okay, if I stuck a fork in here, and I'll try to get a good shot. Those little flat band looking things, those are your heating wires, and those are insulated obviously from ground. So what is going to most likely happen when you stick a fork in the toaster or a knife or whatever, even your finger, if you stuck it in there while it was on, good luck touching that without touching any part of the toaster that isn't grounded. You basically would have to play a game of Operation just to touch that, and then you wouldn't feel anything. If I touched a portion of that and then this, I would get a pretty decent shock, just merely because it's just shorting out from here to here through my finger or whatever. Not very much resistance there, but there's essentially no danger in any of this type of stuff. It's really not very dangerous. It's not as dangerous as people should make it out to be. That's my whole point. And if I had a knife here, it would, like I said, touch this and touch that heating wire right there. So your current would only really flow from here back to the frame. You would essentially have 0 volts going from you to ground. So you'd be safe either way. Yeah. You'll be pretty hard pressed to actually kill yourself. I mean, you gotta be trying nowadays with 120. Okay guys, so that's a wrap of this video. Just talking about the dangers of 120 and how they're kind of overhyped. So I hope you guys enjoyed this video, and I'll catch you in the next one.